At some point after 60, many people begin to notice subtle shifts in their bodies. Energy becomes less predictable. Recovery takes longer. Joints feel stiffer in the morning. In the United States and much of the developed world, more than 1 in 4 adults over 60 reports chronic joint pain, and rates of muscle loss accelerate every decade past midlife. Yet from an evolutionary perspective, this stage of life was never meant to be a slow withdrawal from activity. In fact, the human body evolved for something quite unusual among mammals: a long, active post-reproductive life, which raises a puzzling question. If humans evolved to remain capable and functional well into older age, why do so many modern adults begin to decline just when they still have decades of life ahead of them? The answer is not simply aging. It is something subtler and far more revealing, because several extremely common habits in modern life quietly conflict with the evolutionary design of the human body, especially after 60. And once you understand those mismatches, a surprising realization begins to emerge. Your body is not failing. It is responding exactly as it evolved to. I'm Daniel Lieberman, Harvard professor and evolutionary biologist. I've spent my career studying how the human body evolved to run, eat, think, and survive. Now I'm here to help you understand why your ancient biology struggles in a radically modern world, and how to work with it instead of against it. Welcome to the evolution. If you enjoy thoughtful explorations of how evolution shapes everyday health and behavior, consider subscribing. Each episode examines a different puzzle about the human body and the modern environments we ask it to live in. Because to understand what to change after 60, we first have to understand something deeper: why humans evolved to stay active for so long in the first place. And the answer begins tens of thousands of years ago. To understand why certain habits become particularly harmful after 60, we have to start with an unusual feature of human evolution. Most animals do not live very long after reproduction ends. In many species, once offspring are raised, the biological role of the parent is largely complete. Natural selection rarely invests heavily in maintaining the body long after reproductive years. Humans are different. Anthropologists sometimes call this the long post-reproductive lifespan puzzle. Across many traditional societies, humans often remain active, mobile, and socially important for decades after raising children. Grandparents were not simply passive observers of life, they were workers. In hunter-gatherer populations studied across Africa, South America, and parts of Asia, older adults routinely contribute food, knowledge, childcare, and social leadership. Studies of the Hadza foragers of Tanzania show that grandmothers often gather substantial amounts of plant foods that support younger families. In evolutionary terms, older adults mattered a lot. This idea is sometimes called the grandmother hypothesis, the proposal that human longevity evolved partly because older individuals increased the survival of their grandchildren. But here is the critical detail: those older adults were not sedentary, they walked a great deal. Daily movement in many hunter-gatherer populations ranges between 5 and 9 miles, spread naturally across gathering, carrying water, preparing food, and maintaining shelter. Not structured exercise, just life. And that distinction matters enormously. The human body did not evolve expecting intense workouts a few times per week. It evolved expecting frequent, moderate mechanical loading, regular, varied stresses placed on muscles, bones, and connective tissues throughout every single day. This constant low-level activity performed a quiet but powerful biological function. It signaled the body to maintain itself. Bone cells respond to mechanical stress by strengthening skeletal structure. Muscles maintain their mass when they are regularly used. Joints remain lubricated and stable when they experience gentle movement throughout the day. But when those signals disappear, the body begins conserving energy. And this is where evolution reveals something counterintuitive. The human body is not designed to maintain costly tissues unless they are regularly needed. Muscle is metabolically expensive. Bone maintenance requires energy and minerals. So when mechanical loading decreases, when movement drops, when muscles are rarely challenged, the body gradually begins to reduce those investments. Not because something is broken, because from an evolutionary perspective, conserving energy makes perfect sense. And that is exactly where the problem begins. Modern environments have dramatically reduced the everyday movement that once quietly maintained the body throughout life. Cars replaced walking, chairs replaced ground sitting. Household technology eliminated many small physical tasks that once filled ordinary days. Which means the signals that once told the body, "Stay strong, you are needed," have become weaker, especially after 60. What follows are the 7 specific habits that interrupt those signals most powerfully, and what the evolutionary biology actually tells us about why they matter so much. Habit 1. Stop avoiding mechanical load on your skeleton. The first habit to reconsider after 60 is one that feels entirely reasonable, even cautious: the instinct to protect the body from physical stress. After 60, a common cultural message, often well-meaning, is to take it easy, avoid impact, rest if something aches, choose the elevator, skip the heavy bag, and while genuine injury deserves appropriate care, the broader instinct to reduce physical challenge is, biologically speaking, precisely backward. Bone is a living tissue. It remodels constantly in response to mechanical stress. When you apply load to your skeleton through walking on uneven terrain, carrying moderate weight, or resistance exercise, bone-forming cells called osteoblasts receive the signal to strengthen structure. When you remove that load, the opposing cells, osteoclasts, begin breaking bone down. The body allocates resources where the signals say they are needed. In ancestral environments, later life adults did not reduce physical demand. They carried children, foraged, built shelters, and walked several miles daily across varied terrain. The skeleton received continuous mechanical input well into old age, and it responded by maintaining its architecture. Modern retirement environments, by contrast, often involve extended sitting, smooth flat flooring, and minimal load-bearing activity. The signals simply stop arriving. Consider a retired teacher in her mid-60s who walks flat pavement for 30 minutes each morning and otherwise spends most of her day at a desk or on a sofa. She is not sedentary by common standards, but her skeleton is receiving almost no varied mechanical challenge, no incline, no load, no unpredictability, and her bone density responds accordingly over time. The counterintuitive insight here is that discomfort during moderate load-bearing activity is not a warning that the body is failing. It is often the body responding exactly as it evolved to, adapting to a signal it has not received in some time. Resistance training, uneven terrain walking, and carrying moderate loads are not aggressive interventions for people over 60. They are the biological baseline the maintenance program requires. Which leads us directly to a second habit that seems harmless, yet carries surprisingly powerful consequences, and it begins with something nearly all of us do for the majority of our waking hours. Habit 2. Stop sitting in static positions for extended periods. Let's talk about chairs. For most of human history, humans did not sit in chairs. That may sound trivial, but biomechanically, it is a profound difference. Across many traditional societies, people rest on the ground, squatting, kneeling, or sitting cross-legged. These positions require constant, subtle muscle engagement to maintain balance and posture. Ankles flex, hips rotate, knees bend fully, and the spine continuously adjusts. The body is never completely passive. Chairs change that. When we sit in a standard chair, the pelvis tilts backward, the lower spine rounds, and large portions of the body's stabilizing muscles switch off. The hip flexors shorten, the posterior chain disengages. The glutes stop receiving the contraction signals that help stabilize the pelvis. The chair performs the work that muscles once did automatically. For short periods, this is harmless. But when sitting becomes the dominant posture of daily life, and in many modern countries, adults spend between 9 and 11 hours per day sitting, often in long, uninterrupted stretches, something important happens. The body adapts, and not in the direction you want. Over months and years, this accumulates into what clinicians describe as postural dysfunction and what evolutionary biology would describe as a mismatch between the postural variability the musculoskeletal system evolved to receive and the postural monotony modern furniture imposes. After 60, this matters more, not less. Muscle and connective tissue become less forgiving of prolonged static loading. The recovery window after extended sitting grows longer. In places where older adults still sit on the floor, rising up and down repeatedly throughout the day, rates of hip mobility and lower body strength often remain higher well into later life. The simple act of getting up from the ground becomes a form of natural strength training. No gym required, just daily life. The reframe here is not to stand all day. That introduces its own mechanical problems. The reframe is variability. The body evolved to cycle through many positions throughout the day, and each position provides a different set of loading signals to different tissues. Taking a 3-minute movement break every 45 minutes, spending time in a squat or floor-seated position daily, and varying work and rest postures throughout the day are not performance interventions. They are structural maintenance. Now, so far, we have talked about movement, but the next habit involves something most people would never associate with aging at all, and it begins with something we do 3 times a day. Habit 3, stop eating predominantly soft, processed foods. This one surprises nearly everyone. The third behavior involves something most people would never associate with physical decline after 60, chewing. The human jaw and craniofacial skeleton are among the most mechanically responsive structures in the body. Research in developmental biology has shown that the forces generated during chewing directly influence facial bone density, jaw alignment, airway architecture, and even neck and cervical spine posture. This is not a marginal effect. The mechanical loading of chewing is a primary maintenance signal for a significant portion of the human skull. For most of human evolutionary history, diets required substantial masticatory effort. Fibrous tubers, raw vegetables, dried meat, seeds, and unprocessed grains all demanded meaningful chewing force. Contemporary ultra-processed foods, soft breads, blended meals, protein shakes used as full meal replacements, heavily processed convenience foods require almost none, and this creates a problem no one anticipated. In adults over 60, the jaw muscles and surrounding structures are already receiving reduced mechanical stimulation simply due to the gradual dietary transitions of middle age. Adding predominantly soft food intake reduces that stimulation further. The result over time can include reduced bone density in the jaw and surrounding structures, altered bite mechanics, and changes in how the airway is supported during sleep, contributing to breathing quality issues that are already more common in later life. This is not an argument against soft foods after dental procedures or illness. It is an argument for deliberately including foods that require real chewing effort. Raw vegetables, nuts, fibrous fruits, less processed whole grains, as a regular, non-negotiable part of the diet. The jaw, like the long bones of the leg, is maintained by the mechanical signals it receives. Remove those signals, and the maintenance program goes quiet. Let's take a moment to step back. If you remember nothing else from today, remember this. The human body after 60 is not in a phase of inevitable decline. It is running an ancient maintenance program that requires specific biological inputs. Every habit on this list represents a signal that program depends on and that modern life has quietly removed. That is the core of what we are exploring. Now let's continue with habit 4. And this one is about something that modern culture has quietly redefined as a personal choice, when in reality, your brain was never designed to function without it. Habit 4, stop treating social disengagement as acceptable rest. The fourth habit to reconsider is social withdrawal, particularly the gradual, almost imperceptible retreat from community that often accompanies retirement, reduced mobility, or the natural attrition of social networks that comes with age. Human beings evolved as intensely social organisms. The cooperative structure of ancestral groups, shared childcare, collaborative foraging, knowledge transmission, collective decision-making was not a cultural luxury. It was the primary survival mechanism of our lineage. The human brain, which is metabolically expensive and slow to develop, was shaped in an environment where social cognition was among the most critical functional demands placed on it. What this means is that social engagement is not merely pleasant for the aging brain, it is a biological input that the brain's maintenance systems were built around. Longitudinal research on aging consistently finds that social isolation is one of the most powerful predictors of accelerated cognitive decline and reduced longevity, with effect sizes that rival or exceed those associated with physical inactivity. And yet, in many Western contexts, particularly following retirement, social contact drops significantly and is often replaced by passive solitary activities, television, scrolling, or reading in isolation. Your instincts evolved for a different world. In that world, no adult over 60 would have been functionally isolated. They would have been embedded in a network of kin, cooperative relationships, mentorship obligations, and community ritual. The brain expected that input. It was built assuming it would arrive. Deliberately maintaining or rebuilding social infrastructure after 60 through community involvement, regular shared meals, mentorship, cooperative projects, or even structured group activity is not a wellness suggestion. It is the social loading equivalent of mechanical skeletal loading. The brain maintenance program requires it. And this connects directly to the fifth habit, one that is subtler than all the others, but in some ways the most consequential of the list, because it is the strategy most people are relying on without realizing it is the wrong tool entirely. Habit 5. Stop relying on willpower to sustain health behaviors. Here is where the evolutionary biology becomes genuinely clarifying. The human brain did not evolve in an environment that required sustained executive effort to make healthy choices. In ancestral contexts, movement was structurally unavoidable. It was embedded in the process of acquiring food, water, and shelter. Nutrient-dense foods were the only foods available. Social connection was enforced by the structure of group living. Rest happened when darkness fell. These behaviors did not require continuous self-regulation. They were the default outputs of the environment. Modern environments, by contrast, make health-supporting behaviors optional and convenience-undermining behaviors effortless. The result is a structural mismatch between the motivational architecture of the human brain and the demands placed on it by contemporary life. Willpower is a finite cognitive resource. Using it as the primary strategy for health maintenance is not a character failure when it runs out. It is a design problem. After 60, this matters in a specific way. The executive function networks in the prefrontal cortex, the brain regions most responsible for self-regulation, planning, and delayed gratification, show gradual age-related changes in function. This is not pathology. It is a normal feature of the aging brain, but it means that willpower-dependent strategies become less reliable over time, not more. The more evolutionarily aligned approach is environmental design, structuring the physical and social environment so that health-supporting behaviors are the easy default choice and effort-requiring departures from them are the exception, mimics the behavioral architecture that evolution built humans for. Remove junk food from the house. Build a walking route into a daily routine that does not require a decision. Join a group that moves together. Make the healthy option the one that requires no thought. This is not about discipline. It is about alignment. Which brings us to the sixth habit, and this one involves the brain directly, not in the way you might expect. Habit 6, stop dismissing cognitive challenge as optional. After retirement or major life transitions, many adults settle into routines that are comfortable, familiar, and cognitively undemanding. The same news sources, the same social circles, the same leisure activities. And while familiarity provides genuine psychological value, a diet of exclusively familiar cognitive experiences withdraws one of the most important maintenance signals the aging brain depends on. The human brain evolved in conditions of continuous environmental novelty, new terrain, new social dynamics, new problems requiring creative solutions, new information to integrate and transmit. Cognitive challenge was not a special occasion. It was the chronic background condition of ancestral life. Neuroscience research on what is sometimes called cognitive reserve, the brain's resilience against age-related structural changes, consistently finds that individuals who maintain intellectually demanding activity across adult life show greater functional protection against cognitive decline. The mechanism involves the continued growth and pruning of synaptic connections, the maintenance of neural networks that are strengthened by use and weakened by disuse. And here is where things change. The type of cognitive challenge matters. Passive consumption, watching documentaries, listening to lectures, provides far less neural loading than active production and problem solving. Learning a new instrument, studying a second language, engaging in complex craft or construction, participating in debate, or teaching others what you know. These are the activities that produce meaningful neural loading. Consider a man named Robert. Robert spent most of his career as an accountant. His work involved long hours at a desk. In his early 60s, he retired, looking forward to rest after decades of structured work. Within a few years, however, Robert noticed that his mind felt slower. Conversations that once felt easy required more effort. His doctor mentioned early signs of cognitive change common in older adults. Nothing unusual. But Robert made one change. He started teaching a free bookkeeping class at his local community center once a week. He had to prepare material, answer unexpected questions, explain things multiple ways, and adapt to different people's understanding. None of it resembled structured brain training. It simply restored daily cognitive demand. Over time, Robert reported something that surprised even him. His sharpness returned, not perfectly, but meaningfully. The brain maintenance program expects challenge. When challenge stops arriving, the program responds accordingly. For adults over 60, deliberately scheduling cognitively demanding activities, not as therapeutic interventions, but as the biological equivalent of skeletal loading for the brain, is one of the most evidence-aligned investments in long-term function available. And that brings us to the seventh and final habit. In many ways, it is the one that underlies everything else, because without this, none of the other six work properly. Habit 7, stop treating sleep disruption as an acceptable trade-off. Sleep is perhaps the most powerful single maintenance signal in the human body, and it is the one that modern life most systematically dismantles. During deep and REM sleep phases, the brain undergoes a process of metabolic waste clearance through a recently discovered system called the glymphatic pathway, essentially a flushing mechanism that removes protein aggregates and metabolic byproducts from neural tissue. This process is dramatically less efficient when sleep is fragmented, shortened, or shifted away from the circadian window that the body's biology expects. Circadian rhythms, the roughly 24-hour biological clock that governs nearly every cellular process, evolved in response to the predictable daily cycle of light and darkness. For the vast majority of human evolutionary history, artificial light after dark did not exist. Sleep began reliably near dark, and the body's entire hormonal, immune, and neural maintenance sequence was calibrated to that timing. Modern environments, with their blue-spectrum artificial lighting, late-night screen use, irregular schedules, and climate-controlled bedrooms that interrupt the natural cooling cues the body uses to initiate sleep, systematically disrupt that calibration. After 60, the stakes are higher for a specific reason. The glymphatic clearance process, the restorative hormonal cycles, and the immune maintenance functions of deep sleep all become less robust with age. The body can compensate for occasional disruption in younger years. After 60, the margin narrows considerably. A retired engineer in his late 60s who stays up until midnight watching television, sleeps in a brightly lit room, and wakes multiple times in the night is not simply losing rest. He is chronically interrupting the maintenance processes that his body depends on for everything from inflammation regulation to cognitive function to muscle repair. But the deeper issue is not just duration, it is alignment. Going to bed and waking at consistent times, reducing light exposure in the evening, allowing the bedroom temperature to drop slightly. These are not sleep hygiene recommendations in the popular sense. They are circadian calibration, giving the body the environmental cues it evolved to require in order to run its most critical maintenance functions. Sleep is not passive. It is when the body does its most important work. And treating its disruption as an acceptable trade-off for another hour of television is, biologically speaking, one of the most costly decisions a person over 60 can make. Let's return to the question we began with. If humans evolved to remain capable and functional well into older age, and the evolutionary and anthropological evidence is quite clear that they did, why does decline so often feel inevitable after 60? The answer, as we've seen, is rarely a single cause. It is the accumulation of small mismatches, too much sitting, too little daily movement, soft foods that never challenge the jaw, social withdrawal that the brain was never designed to tolerate, a reliance on willpower that was never meant to carry this weight, familiar routines that ask nothing new of the mind, and a disrupted sleep architecture that quietly dismantles every repair cycle the body depends on. None of these habits emerged because people are careless. They emerged because modern environments quietly removed the physical, social, and cognitive signals that once maintained the human body across a lifetime. For hundreds of thousands of years, movement was not something humans scheduled. It was something life required. Social connection was not something humans had to pursue. It was the structure they were born into. Cognitive challenge was not a class or a program. It was the daily demand of an uncertain world. Modern life changed that equation. Convenience removed many of those demands. Technology reduced physical effort. Furniture replaced the ground. Screens replaced conversation. Climate control softened environmental challenge. None of these changes are inherently harmful, but together they alter the signals the body receives, and the body responds exactly as evolution designed it to. Your body is not failing, it is adapting, which leads to a perspective shift that can be genuinely liberating. Healthy aging after 60 is not about forcing the body into extreme training or heroic routines. More often, it is about reintroducing the kinds of ordinary challenges human bodies evolved expecting. Load the skeleton, move variably throughout the day, chew real food, maintain meaningful social connection, design your environment so that health is the default, challenge the brain with new demands, and protect your sleep as the single most important maintenance window in your biology. These are not optimizations, they are restorations. The human body is not designed for comfort, it is designed for use. And when we understand that simple truth, many of the mysteries of modern aging begin to make a great deal more sense, because capability rarely disappears overnight. More often, it quietly fades when the environment stops asking for it. And when those demands return, even gradually, the body often responds. Not perfectly, but meaningfully. In the next video, we will explore something that follows directly from everything we discussed today, the counterintuitive science of why humans evolved to need boredom and what happens to the aging brain when novelty and meaningful challenge are permanently removed from daily life. If today's conversation gave you a clearer picture of how your body actually works, I hope you will subscribe and stay with the series. The science only gets more interesting from here.